Welcome to section 3 of this chapter. So, in this section, we're talking all about solving these polynomials, okay? And the cool thing is, this actually gives us the opportunity to discuss factoring again. So here, or in chapter 4, you reviewed basic factoring skills, right? Things that you learned back in the 9th grade. Now, we're going to take that a step further. We're going to talk about how can we factor things of higher degrees, of higher powers. All right, and I get really excited. I love these sections because I think factoring is fun. It's just a puzzle that you need to put together. Well, now there's an element of, there's different styles of factoring that I'm going to show you. Specifically, we're going to cover 4 styles of factoring within this chapter, within this section itself. So today's method, we're going to factor out a GCF. So we're going to have a greatest common factor that we can factor out and then solve from there, okay? So there's several scenarios that can happen with a quadratic that you have left. So first let's start with that factoring out the GCF. So in this case, notice x cubed, 22x squared, 21x. So notice the x is in every single term, right? So when the x is in every single term, you can actually factor that x out. When you do that, it decreases the power of everything by 1. Okay? Decreases those exponents of each one by 1 because I'm taking one of the x's out. Well, now the question is, that's the first step of everything today. Factoring out the greatest common factor. Well, now we're going to talk about what to do from here. Well, hopefully you can see in this instance, this thing actually factors again. That quadratic that we have left is going to factor a second time. X and x give me the x squared. 1 and 21 will multiply to 21 and add to 22. So here, our first strategy is that the remaining quadratic will factor again. Okay, so factor out the greatest common factor, then factor the quadratic that you have left. Okay, and then the final step, we are talking about solving here. We want to find the solutions, find the zeros. So what that means is now that x could be 0, the x plus 1 could be 0, meaning negative 1 in there would create the 0. X plus 21, or again, meaning a negative 21, would make that thing 0. Okay, so you do always have to take it that final step to tell me what are the actual solutions. Okay, well, those 3 values are the solutions. Those 3 values are what make those parentheses 0. So again, this is a main goal of everything on this first page. You're always going to be able to factor something out first. For this next one, I can actually factor out a 2x. When I do that, I'm going to end up with this left. And again, with that, what we're talking about is now it factors again. That quadratic that's left behind, I can actually get it to factor a second time for me. X and x give me the x squared. Here, because the 45 is positive, it tells me I'm looking for 2 numbers of the same sign. The negative 14 tells me that sign is negative. So here I'm looking for 5 and 9. Because those multiply to positive 45, add to negative 14. And again, now we can say, well, that means 2x would have to be 0. Okay, and the nice thing is, divide the 2 over. So x is 0. X minus 5 needs to equal 0. So again, obviously sometimes you can skip that step. Just say, hey, I know that means x must be 5. For the x minus 9 to be 0, obviously x would have to be positive 9. So when you're always looking for what would make each of those pieces equal to 0, that becomes your solution. All right, so let's keep plugging away. So here again, I see a greatest common factor. I can factor an x out of all of these. And now again, the idea of this first page is once I do that, I can factor a second time. Okay, the quadratic that's left behind can factor again. Now this time I threw a little twist at you. Remember those more difficult factorings? So because I have a 2x squared, that means this must be a 2x and an x. And then this must be a minus 5. Oh, and a plus 2. Because a negative 5x and a positive 4x, that gets me the negative 1x there. Right, so sometimes you will have to do your more difficult factoring methods as well. Those trickier ones where a isn't always 1. But now we're going to go through, we're going to say, all right, so x must be 0, 2x minus 5 has to equal 0. This is the one I do always recommend you actually show me this work, because you're going to have to add the 5 over and divide by 2 to get your solution of 5 halves. Then the x plus 2, in order for that to be 0, x would have to be negative 2. So still getting your 3 solutions. And again, show as much work as you feel necessary to make sure you're getting the right answer. For this last one, I put a little caption on there because we have a situation. It doesn't look like the other ones. All the other ones have in common that they're set equal to 0. And remember, in order to factor, that actually is a requirement in the factoring process. So the first thing you would have to do in this one is remember, you always need this set equal to 0. All right, so subtract the 63x over. Now it equals 0. Now I can begin this factoring process. And again, I begin this factoring process by pulling out that greatest common factor, dividing out the x. And now I'm going to factor again. X and x give me the x squared. A positive 9 with a negative 7 is going to multiply to negative 63 while adding to positive 2. And now I just take each one of these and set it equal to 0. So x would be 0. In order for x plus 9 to be 0, x would have to be negative 9. And in order for x minus 7 to be 0, x would have to be 7. Right? So in general, that's a big idea of this whole thing. Okay? Pull out your greatest common factor, then factor again. Now, I do want to show you another thing that can happen. All right? So again, here we're going to pull out our greatest common factor. All right? Well, our greatest common factor here, this time, is going to be an x squared. And then we have x squared minus 49 left. Okay? Now, this technically you could factor again. Okay? Now here, that's going to produce an x equals 0. But notice the exponent means with multiplicity 2. Okay, so that actually has a double solution at that negative 2. Now, when I set this x squared minus 49 equal to 0, okay? Because remember, both pieces can be set equal to 0. Well, also remember, you can solve by square rooting. Sometimes it's actually easier, and something that's going to come into play a lot later is I could solve this by square rooting it. So I could add that 49 over, square root both sides to get my plus or minus 7. Okay, so sometimes, and that's the strategy here, the resulting quadratic can be solved by square rooting. Okay, so don't be afraid to use that method. Now, again, I do level with you. That could have been factored. Right, you could have factored that into x plus 7, x minus 7, right? And that would have gotten you the 7 and negative 7 as well. But again, I'm just showing you alternative methods, okay? Other ways that can work. So if you could solve the quadratic by square rooting instead of factoring it, by all means, go ahead and do so. Same thing with this next one. If I factor out the 2x, I get that. So I have this 2x equaling 0. So x would be 0. Then I have the x squared plus 10 that equals 0. And this time I actually can't factor that. It's not a difference of 2 squares. But I can solve it by square rooting. I can subtract the 10 over. And now I can square root it. Well, square rooting it always produces a plus minus. Square rooting a negative always gives me an I. Then the 10 is stuck inside. So maybe you're wondering, when do I know that I can use this method? Well, this method comes from when you have no x term. Okay, so notice here, I had x squared and I had my constant but no x term. Same thing here. I had my square and my constant term but no x term. Okay, so that's kind of the lead in to know that you can use this method is when you only have 2 of your 3 terms for your quadratic. Now, let's talk a little bit again about this, okay? So the first one we did on the left-hand side, we're going to talk a little bit again about what can we do with this now. So, name, well, it's 4th degree, so it's quartic. Excuse me. It has 2 terms, so it's a binomial. And behavior, anything even like this is going to act like a parabola, specifically a positive parabola, because that's a positive 1 sitting out front. So its end behavior is going to start up and it's going to end up. Okay, so again, that's what you're going to have to be able to do for me for the test, to label out all those things. The thing I'm also trying to get you to see is that you can actually sketch this thing. Okay, so we have zeros at -7, 2, 3, 4, 5, 6, 7. I'm sorry I didn't go far enough. At 0 and +7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 6, 7. So again, I apologize. It didn't actually go far enough. So we have zeros there. Those are the solutions that we found. So graphically, those solutions are going to be sitting on the x-axis. We know that we're starting up on the left-hand side. So our function is starting here, coming down, This had a multiplicity of 1, so it's going through that 0. At some point, it's turning around, it's coming back up to get back to this 0. Now, here's where the twist happens. So notice we said that solution of 0 had a multiplicity of 2. Didn't that solution of 0 get represented twice? So remember, that's where it's going to turn around, bounce off of it, right? Bounce off, come back, eventually turn around so it can come up, go through there, and end up as well. So we don't know how low it goes at those two valleys there, but we have a general idea. We have a rough sketch of what this thing is going to look like or what it could look like. Okay, and that's something I know pops up in higher level math. Okay, I know that sometimes they can give you a polynomial and just ask you, hey, sketch this. And you need to know each of these things so you can give an appropriate sketch. Okay, so again, just exposing you to that idea that you're figuring out how to piece all of this together. This is the big picture of what you're doing. Finding each of these pieces is helping you represent the function graphically. Last thing that we're going to do is the resulting quadratic can't be factored or square rooted, so sometimes you're going to have to use the quadratic formula on it. All right, so again, before we can do anything, we need everything on one side. Oh, I'm sorry. So I'm going to subtract off that 6x cubed. Notice I'm putting it in place, so it's in standard form, okay? I don't just want to put that on the end because that's going to mess me up later. And now I'm going to factor out a 3x squared. Okay, that's the greatest common factor that can come out of this one. It's going to have x squared minus 2x plus 6 here, of course, we've talked about whenever you have something sitting out front like that, always just creates a solution of 0, right? And in this case, because it has a 2 again, with multiplicity 2, and then you'd also have to solve this. But notice that quadratic can't be factored. There's nothing that multiplies to 6 and adds to negative 2. So what we end up having to do is it doesn't factor. It has all three terms, so we can't just square root it. So sometimes you're going to need the quadratic formula. Okay, so quadratic formula, again, I know we just reviewed it in chapter 4, but let me put it back on the board for you. Here is what I'm talking about. That is the third and final thing that you may have to do with the resulting quadratic. Okay, so negative b, well, b is already negative 2, so that'll be a positive 2 plus or minus square root negative 2 squared minus 4 times a times c all over 2 times a, 2 plus or minus. So here we have 4 minus 24, so that'd be a negative 20. We already talked last chapter about how to simplify that square root of negative 20, right? So we know we get an I because of that, because we're square rooting a negative, so I'm just going to do that first. I'm going to break this up into 4 and 5, because the square root of 4 is the number 2. So we have 2 plus or minus 2I square roots of 5 all over 2. Well, notice all those 2's. I'm going to divide everything by 2 to just turn them into 1's. So 1 plus or minus 1I square root of 5. Okay, so when using the quadratic formula, again, just like we did back in chapter 4, also recall how to simplify the square roots. Okay, that is something that you're going to have to know how to do. So a lot of good stuff today, okay? A lot of really, really good factoring and review of the quadratic formula. And just good review of stuff we've already done in chapter 5, actually. Just general good review. So what I want you to do with all this great stuff we just talked about is I want you to write your summary, the big picture here, okay? So write out a few details, things that you think you should definitely remember, and then make sure you come back ready to do your practice work on this lesson when we're back in class together.